Volume is a measure of the space which something occupies. We use volume to measure the quantity of liquid. For instance, we use volume to measure the amount of coffee that we have in a cup. If I have a cup of coffee with this much coffee in it, most of us wouldn't be very pleased because we can see that the volume of coffee in this cup simply isn't 1 cup's worth, or that we haven't gotten a full cup of coffee, and this doesn't make us very pleased. So we use volume to measure the quantities of lots of liquids. We buy our coffee by the cup, we buy milk by the quart, which is another measure of volume. We buy gasoline by the gallon, which is another measure of volume. Most of the glassware we use in the chemistry laboratory has volumetric gradations on it. For example, these beakers show the volume in milliliters. Beakers, as you remember, are used to contain or to pour liquids, and for this reason they have spouts. This Erlenmeyer flask also shows volumetric gradations. Erlenmeyer flasks, as you remember, are used to mix or swirl liquids, and therefore they have a narrow mouth to prevent spills and a broad base to contain the liquid. These gradations are not particularly accurate and are used only for approximate measures of volume. If I want to accurately measure the volume of a liquid, I have several choices. One choice is a graduated cylinder. A large graduated cylinder, such as this one, would be used for measuring relatively large volumes, somewhere around 100 mL or less. We also have smaller graduated cylinders, and these can be used for measuring smaller volumes, in this case 10 mL or less. Another choice for measuring volume is a pipette. And a pipette is basically a very thin tube that we draw liquid up into. This is a 10 mL pipette, and it holds a total volume of 10 mL. We have smaller pipettes. This one, for example, is a 5 mL pipette and holds a maximum volume of 5 mL. Another choice for measuring volume is a BURET. This is a BURET. You can see that it has volume gradations on it. Again, it measures volume in milliliters. We fill the BURET with liquid, we turn the stopcock so it is open, and then the liquid can run out of the BURET. Now we would like to measure the volumes of some liquids. But before we do that, it is necessary to discuss the meniscus. A meniscus is the top of fluid in a tube. As you can see, when we put a liquid such as water in the tube, it isn't straight across the top, it comes down this way. We always measure the volume of a fluid in the tube from the bottom of the meniscus, and that line is shown right here. So this line down here tells us the volume of the fluid, not this one up here. Suppose I wish to measure a volume of 50 mL. A good choice to do this is this 100 mL graduated cylinder. Here I have some liquid, and I'm going to pour 50 mL of it into the cylinder. In order to really see the volume of liquid in a cylinder, my eye must be at the same level as the meniscus of the liquid that I'm pouring in here. So I need to get very close to this cylinder. As you can see, the volume is exactly 50 mL. Now let us measure 5 mL using this smaller graduated cylinder. The method is exactly the same as for the large one. Again, I pour liquid into the cylinder carefully, get my eye at the same level as the liquid, and I continue to pour it in until I have exactly 5 mL. Another thing that we can use to measure volume are pipettes. This pipette has a total volume of 10 mL from this line down to here. We can use the pipette to suck some liquid out of this beaker and then deliver it to another vessel, such as this test tube. We do not use our mouth to suck up the liquid. Instead, we use this. This is called a pipette bulb. There are several valves in this bulb. This one up here is letter A, is for air, letting air out of the bulb. This one down here is S, is for suction, for sucking liquid up. And this one here is E, and that is in order to push this in order to empty the pipette. The first thing I need to do with this bulb is get the air out of it. If I just try pressing on it, nothing happens. If I push the A valve in and then press on it, the bulb deflates. Now I can place this bulb on the top of the pipette. I do this carefully so that I won't break the pipette or injure my hands. Now I'm going to put the pipette into the liquid and push S. As you can see, the liquid is rising in the pipette. When it gets as high up in the pipette as I want it to go, I take my fingers off S. Now I check the volume, again looking at this at eye level. This has stopped exactly at 10 mLs. Actually, it has stopped at 0. This means that the pipette now contains 10 mLs of liquid from the 0 line down to the 10 mL line here. If I wish to deliver 10 mLs of fluid to this test tube, I then place the pipette over the test tube and push E for empty. As I do this, you can see that the liquid starts to run out of the pipette. Again, I have to watch at eye level, stopping the pipette when the meniscus rests exactly on 10. Now I'm going to use the same pipette to measure 7.5 mLs. There are several ways I can do this. This time I'm going to fill the pipette again up to the 0 line, and in order to do that I have to push on the valve marked S. Again, I need to check the fluid volume to see that the meniscus sits on 0. Then I move the pipette over to the tube into which I'm going to empty 7 mLs. And this time I am going to empty the tube down to 7.5 right here on the pipette. Then I'll let the fluid run from 0 down to 7.5, and I will have 7.5 mLs in my test tube. As you can see, I have delivered exactly 7.5 mLs of liquid to the test tube. If we want to measure a very small volume, it is wiser to use a smaller pipette than this 10 mL one. If I want to measure 5 mLs or 1 mL, as I'm going to do in this case, I might use this 5 mL pipette. It is almost exactly the same as the 10 mL one, except that it holds 5 mLs from the 0 line at the top down to the 5 mL line at the bottom. Again, I'm going to use a pipette bulb. Remember that I have to get the air out of it first, and in order to do that, I need to push on the A valve and squeeze the bulb at the same time. Then I can insert the end of the pipette into the bulb. Now I can suck up liquid. In this case, I am going to suck it up to the 0 line. Notice that this tube fills much more quickly than the 10 mL pipette. Again, I need to have my eye at eye level in order to see the meniscus and to see that the pipette is filled to the 0 line right here. Now I can deliver 1 mL of liquid to this test tube, again by pushing on the valve labeled E and allowing the liquid to run out to the 1 mL mark on the pipette. You can think of the burette as being a long, thin pipette, or as being a very, very thin graduated cylinder. The first thing that we need to do is to fill the burette with liquid. This can be done by just pouring liquid from a beaker into the top of the burette. You have to do this carefully because you don't want to overfill the burette and have the liquid running all over the place. Now we have to let fluid run out of the burette so that we fill this nose piece with fluid also, and I do that by opening the stopcock. Notice that there are some air bubbles in here, and I will let fluid run right through the burette until all of the air bubbles are out. The next thing I have to do is make sure this is filled exactly to the zero line up here. In order to do that, I have to move this whole burette down because I'm rather short. In order to move it down, I open the clamp, and I do that by pushing this way. Now I can move the burette down, and then I can clamp it back into place. Okay. Now again, I have to get my eye so it's right at eye level with this zero line. And then with my fingers down here, I'm going to open the stopcock and let the fluid run out. And as we said before, I have to make sure when I do this that my eye is at the same level as the mark that I'm looking for. As you can see, the meniscus is going to land right on the zero line. Now that we have the burette filled, we can use it to measure volume. In many kinds of experiments, we are going to be letting material out of a burette run into a flask. Let's let some of this material run into this flask. In order to get the burette into the flask, I have to pick it up again. Again, I open the clamp, raise the burette, and then make sure that the clamp has back tightly in place before I let go of the burette. I set the burette underneath this flask underneath the end of the burette. And now I can open the burette and allow fluid to run into the flask. I can let this run for some time, and then I will be able to measure the amount of fluid that has run out by looking up here at the top. If we have finished the reaction we're doing in here and we've let all the material in that we need, we close the stopcock by turning this piece horizontally. Then we read the volume of material which has run into the flask up here. As you can see, the volume that we have let out is 7.6 mLs. Notice again that we have measured from the bottom of the meniscus. As we have already said, volume is a measure of the space occupied. Most pieces of laboratory glassware have volume gradations marked on them, as do these two beakers and this ERLENMEYER flask. As we said earlier, the volume gradations on these things are not particularly accurate. And when we wish to accurately measure volume, we use special pieces of glassware designed for that purpose. Today we look at a couple of these. They include graduated cylinders, pipettes, and a burette. By using the proper glassware and being very careful, it is possible to accurately measure volumes of liquids.